We're going to talk about how to classify the zeros of a polynomial. Okay, so before we can do that, we need to start talking about the types of numbers. All right, and in our numbers, we have now learned that there are real numbers, okay, and there's also imaginary numbers. So these are the big subgroups right here, okay? And a number really can't be both. It's either real or it's an imaginary. So these are two separate categories. Well, let's start with the imaginaries, which we learned this year. Imaginary number could be like 2i. It could be a complex number where it's a real and an imaginary part, but it still makes it an imaginary number. Or it could be something like I square root of 5. Okay, so those are your imaginaries. Well, all of the other numbers that don't have an I, these are our real numbers. Well, real numbers can be then divided into two subcategories. And these categories are rational or irrational. Now, rational numbers, okay, these are your whole numbers, your integers, fractions, and decimals. So numbers like 2 is rational, 0 is rational, negatives are rational, okay? It could be fractions, okay? So basically the definition of a rational number is any number that can be expressed as a fraction with a whole number in the numerator and a whole number in the denominator. So even decimals like, even fractions like 2/3, which go on forever, it's still a rational number. And it could even be like a mixed number where it's like 5 and 1/2 and stuff like that. So all of these are rational numbers. So what are irrational numbers? Irrational numbers would be maybe like the square root of 2, where the decimal would go on forever and never end. And it can't, well, more importantly, it can't be written as a fraction. Or pi is a famous irrational number. Okay, so those are your two subcategories for the real numbers. However, if a number is imaginary, we don't classify imaginary numbers as rational or irrational. If a number has an I, we just say it's imaginary and that's it. So let's look at our first example. Okay, so what we're going to practice doing is we're going to do stuff where maybe a polynomial is given in factored form. So 2 times x minus 2 times x squared plus 3, and then times x squared minus 2x minus 5, okay? And just by looking at this polynomial in factored form, we're going to be able to tell these things about it, okay? We're going to tell what the degree is, what the constant term is, and what the lead coefficient is, okay? And then we're going to tell how many of the solutions are real and the number of complex or imaginary zeros, okay? And then we're going to tell of the real ones, we're going to see how many of those are rational and how many of those are irrational. Okay, so pause this if you need to, but get this down so now it can kind of become like a fill in the blank, okay? This is the template for which we're going to work through this. Let's start with the degree. So if we were to multiply this all together, I don't think we actually need to, but if we take an x and times it by an x squared and times it by another x squared, we're going to end up with x to the 5th power. So what we're talking about right here is a 5th degree polynomial. The constant term is going to be the result of taking this constant -5 times this constant 3 times this constant -2, and then of course all of that would be multiplied by this a value out in front, okay? And so the constant's going to be 2 times -2 times 3 times -5. What are we going to get when we do that? The constant is going to end up being 60, okay? And so then the leading coefficient is going to be the result of multiplying all of the first terms. So we're not going to figure out all of the middle terms without multiplying it, but if we take x times x squared, but then multiply everything by the 2 out in front, the leading coefficient is going to be 2. Okay, so that's how we can get some initial information, and it just so happens that the constant term and the leading coefficient are particularly important. So now what I do is I kind of go through and I look at each factor and I kind of think about solving it, right? This factor would yield x equals 2. This is one real root, okay? Not only is it real, but it is a rational root because it's a whole number. this right here, we're going to minus the 3 over. I'm going to do my work right here so you can see my thinking. We're going to minus the 3 and we're going to square root both sides. So this factor is going to yield the root plus or minus I square root of 3. This is going to make 2 complex roots. Okay, and don't forget that plus or minus, because those complex roots are always going to occur in pairs because it'll always be plus or minus. Now we have this root right here, okay? And it's going to be and it doesn't factor more. So that means that we're going to have to use the quadratic formula. And if we use the quadratic formula, it's going to be 2 plus or minus. Now, what I want you to do is get your calculator. The most important part of this is the discriminant. And the discriminant, okay, and that's the part that's going to go underneath the radical. The discriminant is going to be b squared, which is 4, minus 4 times the a value times the c value. And when you do the discriminant, that means that there's going to be a 24 underneath the radical. So here's the thing, I don't need to simplify this because it's not exactly that I need to say what the roots are, but the fact that that discriminant is positive means that this factor is going to yield 2 real roots. And not only that, the fact that this 24 is not a perfect square tells me that these roots are going to have a radical, and it's going to be 2 irrational roots. Okay, so let's take everything we just talked about and see if we can organize this. I see right here that there's 1 real from this factor and 2 reals from this factor, so 3 real and 2 complex. That needs to add up to make the degree of 5, which it does. Okay, now of the real roots, when I look at this, okay, I see that there is 1 rational root here and 2 irrational roots that would come from using that quadratic formula. So there's 1 rational root because it's a whole number. The irrational root comes from that trinomial, and so 1 plus 2 gives me 3. Okay, so that's what we're going to do, is just be able to look at factors and be able to determine and classify using the correct vocabulary what kind of root those are. All right, example 2. So what if we're not given a polynomial in factored form and we're given, so say we need to classify the roots or classify the zeros, right? This is the same word. X to the 5th minus 3x to the 4th minus 16x plus 48 equals 0. So now, unfortunately, we need to factor this because it was not already given to us in factored form. So let's go ahead, and I recognize that this is a factor by grouping, okay? So we're going to group the first 2 terms. I'm going to turn this into plus a negative 16 plus 48 so we can group the second 2 terms. All right, let's take out a GCF, which is x to the 4th, and the result is x minus 3. Now over here, we're going to factor out a negative 16, and the result is going to end up being an x minus 3. So again, we're not quite factored, okay? When we have these 2 underlined parts, we kind of get rid of this right here. So what does both of these underlined parts have in common? They both have an x minus 3 in common, with an x to the 4th minus 16 left over. Now what we need to recognize is use our factoring skills to factor completely, okay? And I see right here that this is the difference of 2 squares. So this is going to factor, the x to the 4th splits up, the 16 is going to split into 4 and 4, and it's going to go plus minus. I actually see right here that we have the difference of 2 squares again. So our final factored form, x squared plus 4 doesn't factor, but x plus 2 and x minus 2 does factor. Okay, so now what we're going to do is let's think about what the roots are. So what we're going to tell is we're going to be able to look at those factors and tell how many are real and how many are complex or imaginary. And then of the real ones, let's tell how many are rational and how many of the roots are irrational. Okay, so as you get better at this, you will actually find that you can tell a lot of this just by looking. But let's do this for now, okay? This first factor yields x equals 3, which means it's one real, and not only is it real, but we can also say that it is a rational number, okay? Well, this factor, if we take x squared plus 4 and we minus the 4 over and square root both sides, this is going to give us 2 complex roots, okay? And we don't take complex roots and give it a subcategory. If it's imaginary, it's imaginary. There's no such thing as a rational imaginary. This is going to give x equals -2, which means it's one real, and this is a rational number. And this is going to yield x equals 2, which is real, and it is a rational number. So, like I said, it's good to write this out, but as you get better, you might be able to look at a factor like this and just know that it yields 2 complex, okay? So you'll get a little bit quicker at this where we don't have to write out all the parts in green. So let's count this up. There's 1, 2, 3 reals, 2 complex, which means it needed to be a 5th degree polynomial, which it is, okay? Of the real roots, okay, of these real ones right here, how many are rational? And actually all 3 of them are rational, and in this case there were no irrational zeros. So that's what we're going to practice, okay, is using that vocabulary to classify the types of roots and continue practicing our factoring.